Light should never lie. But in the cold silence between the stars, something has begun to twist that truth. It begins with a visitor called 3I Atlas, a lonely wanderer from beyond our solar system. And with it comes a paradox that should not exist. Imaging shows the shadow of 3I Atlas drifting in the wrong direction, not following the light, not obeying the source that creates it, but sliding backward, opposite the illumination, opposite logic, opposite everything geometry teaches us. A shadow cannot reverse direction. Every diagram says so. Every law of light agrees. Yet the shadow of 3I Atlas does exactly that. Frame after frame, calibration after calibration, the same unsettling shift appears. A backward motion where no backward motion should be. This is not a trick of perspective, not an artifact, not a sensor error. The movement repeats with a calm and deliberate certainty, as if the universe itself is performing a quiet demonstration. A reminder that even the simplest ideas can crack under the right pressure. Think of a sundial in your backyard. The sun crosses the sky. The shadow moves with it. Now imagine that shadow drifting the other way, not slowly, not subtly, but undeniably, as if the sun reversed its path, as if time leaned in the wrong direction. That is the feeling scientists faced when the images were aligned. A creeping realization that something older than physics had been disturbed, because shadows are supposed to be honest. Shadows reveal shape. Shadows reveal orientation. Shadows reveal truth. But the shadow of 3I Atlas hides something instead. Something buried in geometry. Something the eye can see but the mind refuses to accept. If a shadow breaks the rules of light, what does that say about the object casting it? What does that say about the space around it? What does that say about light itself? This is the doorway to a deeper mystery. A puzzle that begins with a simple question. Why is the shadow wrong? And what force is powerful enough to reverse the most basic law of illumination? The story of 3I Atlas begins on a quiet night in early April. A routine scan. A familiar pattern of automated sweeps across the darkness. Astronomers were not searching for anomalies. They were not expecting visitors. They were simply watching the sky. And then the alert came. A faint streak. A gliding point of motion. Moving just slightly too fast. Cutting just slightly too sharply, behaving just slightly too differently from the long list of known objects drifting through our solar system. The survey telescope that spotted it flagged the track instantly. Follow-up observations were scheduled within hours, and as measurements accumulated, a strange truth emerged. This object was not born in our neighborhood. Its orbit was hyperbolic, too open, too steep, too wide. The signature of something that had crossed the interstellar void, just like Oumuamua, just like 2I Borisov. 3I Atlas was another traveler from outside the sun's domain, a messenger from a distant star system, carrying with it the physics of a place we have never seen. At first, nothing seemed unusual. Its brightness, its profile, its trajectory, all consistent with an icy interstellar fragment being gently sculpted by solar radiation. Astronomers tracked it, modeled it, measured it. Everything behaved as expected until the shadow appeared. The first anomalous frames came from a deep exposure sequence, a long stretch of silent imagery taken to refine the shape of the object. The goal was simple: determine rotation, surface roughness, reflectivity. Standard procedure for any newly discovered interstellar visitor. But when analysts overlaid successive frames, a problem emerged. The dark region cast by 3I Atlas did not stay in the position geometry predicted. It shifted, not with the sun, not with the angle, but against it. A slow backtracking motion that made no physical sense. Teams repeated the analysis. They increased contrast, reduced noise, ran it through multiple pipelines. The result did not change. The shadow moved backwards. To understand why this mattered, we must return to the fundamentals of celestial observation. Shadows in space are precise. They tell us orientation. They tell us rotation. They reveal subtle details like surface ridges and reflective asymmetry. And above all, they follow the source of light with unwavering obedience. But 3i Atlas rejected this obedience. Its shadow acted like a pendulum moving against its own push, a contradiction embedded in the image itself. The first speculation was instrumental error, a faulty calibration, a misalignment, a software artifact. But multiple telescopes confirmed the effect. Ground-based, orbital, different cameras, different sensors, different conditions. The backward shadow remained. At this point, the discovery passed from routine classification to urgent inquiry. Researchers began to ask deeper questions. What kind of surface could create such an effect? What geometry could reverse the direction of darkness? Could internal reflections be responsible? Could the object be tumbling in a way that created an illusion? Or was something more exotic at play? The shadow anomaly pushed the object into scientific spotlight. 3i Atlas became a puzzle piece that did not fit the picture. A visitor carrying a question instead of an answer. And as astronomers dug deeper, as they reconstructed its motion through space, a new idea emerged, one that would shape the entire investigation. The paradox was not simply a shadow moving backward. The paradox was geometry refusing to behave. To understand the backward shadow of 3i Atlas, we have to return to the language of geometry. Not theoretical geometry, not abstract diagrams, but the simple physical geometry of light in open space, the kind you can trace with a single beam and a single object. Light travels in straight lines. It illuminates whatever it touches, and wherever an object blocks that light, a shadow forms behind it. This principle does not bend, it does not improvise, it does not break. For a shadow to move opposite the light, something extraordinary must be happening, something beyond the ordinary logic of illumination. And so scientists began to test every possibility, one by one. The first idea was rotation. If 3i Atlas spun in an unusual pattern, if its surface contained deep concavities or irregular pits, perhaps the shadow could appear to shift in unexpected ways, like the illusion of motion created when a jagged rock glints unevenly under a flashlight. But measurements of its rotational period revealed nothing strange. No chaotic tumbling, no precession, no sudden torque. Its spin was smooth, predictable, not nearly complex enough to create a directional reversal. Next came the hypothesis of surface geometry. What if 3i Atlas possessed a mirrored region, a reflective facet, a polished crust capable of bending light around itself? Could this shape redirect illumination in a way that fooled observers? Could light skim its surface and create a phantom reversal? Models were built. Simulations were run. Every configuration failed. Reflective surfaces can distort a shadow. They can stretch it, blur it, sharpen it. But they cannot force it to move backward relative to the illuminating source. Not in a vacuum, not under linear illumination, not anywhere the laws of optics hold true. The next idea stepped into more exotic territory. Could 3i Atlas contain a translucent shell? A thin layer of material that refracted light in ways that mimic a reversal. Something like an interstellar ice lens, bending and redirecting beams through internal channels. But again, the numbers refuse to cooperate. Refraction alters brightness, it alters shape, but it does not invert illumination direction. It cannot create a shadow that drifts against the light. A lens does not command a shadow. A lens only redirects light itself. And so the investigation returned to pure geometry, to the physical relationship between the object, the light, and the observer. This is where the research took a darker turn, a more uncomfortable turn, because there was one remaining possibility, one that does not require breaking physics, but bending perception. What if the light source was not where we thought it was? What if 3i Atlas was interacting with sunlight in a way that distorted the apparent angle? A thermal plume, a faint jet, a subtle emission, like the outgassing seen on some comets. A push of material invisible to the eye, but powerful enough to redirect incoming beams before they reach the surface. Yet imaging detected no jets, no plumes, no thermal trails, no detectable emissions. 3i Atlas was inert, cold, silent. Still, the shadow moved backward. At this stage, scientists began to explore a more radical idea. A possibility rooted in pure mathematical symmetry. If an object contains surfaces angled in such a way that light from different directions overlaps, if geometry folds in on itself, if illumination crosses through a narrow band of converging planes, then a shadow can behave in non-intuitive ways. Not reversed, but appearing reversed. This concept is known in advanced imaging as pseudo-inversion, a rare phenomenon where the shape of an object redirects the observer's perception of where a shadow should fall. It is not supernatural, not impossible, but it requires an extremely specific arrangement of cavities and reflective grooves, the kind of geometry nature almost never produces. The kind of geometry that would have to be carved, assembled, or shaped through forces we have not yet understood. 3I Atlas might not simply be a rock drifting through space. It might be a structure, a shard of something larger, something built, or something sculpted by processes alien to our solar system. A shape capable of tricking light, a shape capable of bending geometry, a shape capable of making its own shadow move the wrong way. This is where the mystery of 3I Atlas deepens, because once scientists accepted that the backward shadow was real, once they ruled out error, illusion, instrumentation, they began cataloging the strange details that orbit this anomaly like fragments of a larger truth. The first strange fact is the surface signature. 3I Atlas reflects light unevenly, not in the random scatter you would expect from a natural object, but in crisp patches, sharp lines, segments that behave almost like facets on a carved structure. When these reflections are mapped, they form patterns that repeat every rotation, like the markings on a machine, not the chaos of fractured ice or rock. Another oddity comes from its thermal behavior. When sunlight strikes it, the temperature map rises in a way that suggests hollow regions beneath the surface. Internal voids, chambers, or tunnels, not smooth, not spherical, but branching, like the architecture of something designed. Thermal peaks align with these voids, as if heat is channeling through internal corridors, creating hotspots that should not exist on a simple interstellar shard. Then there is the paradox of its brightness curve. Natural bodies in space have predictable fade patterns as they rotate. 3I Atlas does not. Its brightness drops sharply, then rises sharply, at intervals that correspond to the same angles where the shadow reversal becomes strongest. Whatever causes the backward shift is tied directly to its reflective rhythm, a rhythm that repeats with mechanical regularity. There is also the matter of its approach vector. Most interstellar objects follow smooth gravitational arcs, but the incoming path of 3I Atlas shows a micro-deviation, a tiny lateral drift. Something nudged it, something very faint. Not enough to be a jet, not enough to be a natural outgassing burst, but enough to imply a prior interaction, a collision, a separation, or perhaps an ejection. Some astronomers propose that 3I Atlas might be a fragment, a broken piece of something larger, something shattered long ago. If that is true, then the backward shadow may be a clue to the shape of the original structure, a relic of alien geometry, a shard of a design no longer whole. Then comes the paradox most experts fear to discuss openly. The shadow does not simply move backward. It moves backward at a rate that matches a specific ratio, a fixed geometric proportion, a constant offset, as if the reversal is not random, not chaotic, but encoded, following a rule that has not yet been deciphered. You can imagine the discomfort this creates. A shadow obeying a mathematical rule, a shadow defying the laws of light, a shadow aligning itself with an internal geometry instead of an external source. The next layer of strangeness appears in archival data. Old survey frames from years before the official discovery were reprocessed. Frames that captured faint moving points no one noticed at the time. Several of these appear to include 3I Atlas, far from our system. And in at least 2 of those frames, the same backward shift is present. Subtle, but real. This means the paradox did not begin near the sun. The anomaly traveled with it. Across interstellar space, the shadow inversion is not an environmental effect. It is intrinsic. Another detail that troubles analysts is the lack of any visible dust trail. Most interstellar objects shed material as they warm, but 3I Atlas remains clean. Too clean. Its surface shows no plume, no erosion, no scattering. This raises the possibility that the object is far more durable than expected, or composed of materials we have not yet identified. A final paradox ties everything together. The backward shadow reaches maximum intensity when 3I Atlas is illuminated from a very narrow angle, a near grazing alignment, a razor-thin geometry at this angle. Something inside the object appears to trigger the effect, as if a hidden structure comes into perfect alignment, as if a buried pattern reveals itself only when the light strikes a precise plane. These details form a constellation of anomalies, each one strange on its own. Together, they create a portrait of something far more complex than a wandering interstellar rock. And at the center of that portrait stands the paradox that began it all, a shadow that refuses to follow the light. A contradiction that behaves as if geometry itself has been rewired. If the shadow of 3I Atlas truly moves backward against the light, if the inversion is not illusion, not error, not trick, but an intrinsic property of its geometry, then humanity stands at the threshold of something far larger than a single interstellar visitor. Because a backward shadow is not just a curiosity, it is a message written in physics. A signal that our understanding of illumination, geometry, and structural symmetry may be incomplete. It hints at shapes capable of bending perception, surfaces that can manipulate light without breaking its laws, forms that behave with intention rather than randomness. This leads to a profound implication. If 3I Atlas is a fragment, a shard of a greater object, then the full structure it once belonged to might have used shadow mechanics in ways we cannot yet imagine. Astronomers have begun to model such possibilities. Structures built around controlled illumination, architectures designed to redirect shadows like moving markers, systems where darkness becomes a channel of information, a language written not in light, but in the absence of light. Imagine technology that uses shadow displacement as signaling, a method immune to glare, immune to noise, immune to most cosmic interference. A system that remains readable even across the cold distance between stars. 3I Atlas may contain the remnants of such a design, a geometry that once interacted with light intentionally, perhaps as a beacon, perhaps as a measurement tool, or perhaps as something we have not yet conceived. Scientists are now preparing future instruments capable of deeper shadow analysis. Satellites with higher contrast sensors, optical arrays made for precision shadow tracking. If another interstellar object arrives, we will be ready to study its geometry with more clarity. But the greatest leap may come from missions that follow. Probes that intercept the next visitor, orbit it, scan it, map its hidden cavities and reflective planes, and decode the strange rules it carries. Because if backward shadows exist, if they follow geometric patterns rather than illumination, then they may serve as a doorway to new understanding, not just of interstellar debris, but of how alien structures may channel energy, how light behaves near unusual materials, and how geometry itself can manipulate perception. Some physicists have even proposed using controlled shadow inversion as a tool. If we can replicate the effect, if we can shape surfaces that redirect shadows deliberately, it could lead to breakthroughs in stealth technology, in deep space mapping, in thermal management, or even in signal encoding across astronomical distances. But perhaps the most profound implication is philosophical. A backward shadow challenges one of the oldest certainties in human thought. For thousands of years, we trusted that shadows were simple, honest, predictable. The dark imprint of the world around us, a silent proof of shape and direction. 3I Atlas has changed that. It has revealed that even darkness can lie. Even darkness can mislead. Even darkness can behave with a strange kind of order we have not yet deciphered. And so we stand at the edge of this paradox, watching a visitor from another star drift back into the void, carrying with it a geometry we barely understand, a whisper of a structure long gone, and a shadow that moves in defiance of the sun. As 3I Atlas fades from our skies, we are left with a quiet realization. The universe is not simply vast, it is layered, it is folded, It is built from rules we have only begun to uncover. And sometimes, the greatest mysteries are not found in the light, but in the places where the light should be and is not. A backward shadow, a silent visitor, a fragment from another world, and a reminder that the cosmos still has secrets strange enough to bend geometry, twist perception, and leave humanity staring into the dark, wondering what else might drift our way next.